So good morning. My name is Sujit Roy. I'm an application engineer for EDA Direct, and we are a distribution channel for various companies. And this morning I'm going to be talking about specifically how you can use StarVision Pro for your parasitics and how we can debug them a lot easier than conventional ways with text files. So the agenda that I have, I'll talk about our company and Concept Engineering. They are the company who develops StarVision. Go through some of our customers, talk about some of the product details. And I'll go over some of the common capabilities across the platforms, and I'll explain what I mean by platforms when I get to a slide. Then I'll go specifically into some of the visualization debug capabilities within Spice, talk about the ability to do analog simulation waveforms, and then I'll go into post layout parasitics. I may switch the demos around. I may go into the Spice, then post layout, and then the analog. And then I'll jump into the product demo. So a little bit about EDA Direct. We've been around since '97, and we help customers in high-tech industry with design tools, training, and services. And we represent 4 companies here in the United States. The first one I'll be talking about is Concept Engineering StarVision. Then we also represent Mental Graphics on the West Coast. And some of you may know that Mental Graphics is now being acquired by Siemens. So we do also sell Siemens products. And if there are some products by Siemens that you're interested in, please reach out to us. And another company that we represent is called ClearSoft. If you are in the data management arena, we can help you in that space as well. One of the other products that I do support is to do with the product lifecycle management. If you do develop products, we do have a product called Application Lifecycle Management, ALM, and it's called Polarium. And if you are interested in that space, I'll be happy to talk to you at another time. So let's talk about Concept Engineering. They are the company who's developed SpiceVision or StarVision, and I'll explain the differences why I switch between SpiceVision and StarVision. And they've been around since 1990, and they're based in Germany and used by more than 130 customers, and exclusively distributed in the United States since '97 by EDA Direct. So some of the customers that uses Concept Engineering's tools are listed here. I'd like to drive your attention towards the bottom 4 customers. If you notice, Mental Graphics, Cadence, Synopsys, and Ansys, they're all themselves EDA companies, but they do use Concept Engineering's tools to debug their own tools and also assist their FAEs when they're debugging customer sites. We also have some articles written by various engineers on a semi-wiki page, and again, I'll be sharing this with you. So let's go into some of the details about SpiceVision. So as I mentioned, Concept Engineering, they themselves develop 4 products. And one of them is called SpiceVision Pro, which is a transistor visualization tool. Now, none of the tools I just want to point out are simulation tools. These are visualization tools. So the other tools that they do are for the digital engineers is RTL Vision and Gate Vision. So RTL Vision enables you to visualize RTL, and Gate Vision enables you to visualize post-synthesized netlists. So as time evolved, Concept Engineering was asked by their customers to develop a tool that their analog design engineers and their digital design engineers can work with one product, and they developed a product called StarVision. So sometimes I keep using StarVision or SpiceVision. Specifically with parasitics, we're more interested in SpiceVision, which is under the StarVision umbrella. So if you do have design engineers looking at some RTL designs, we'll be happy to talk to you about StarVision. So the way we like to position the tool is like a, one of these multi-tools. Say, for example, you have the tool itself has a lot of capabilities and features, but there may be only one or two features that you use. For example, let's look at this multi-tool. There's a pair of pliers on the top. It has some knives. It has a can opener. But most likely it's in your toolbox, and you probably just use the pliers. You may not ever need the can opener or the nail file, for example. So we like our customers to think of StarVision being like a multi-tool, that it's available for you. Not necessarily will you use it every day. We hope you do. But most of our customers, they find an area or they find a particular capability that they like and they gravitate towards, and they use it year in, year out. And that's the way we like to, we hope our customers use this tool. So let's talk about some of the capabilities. So the tool reads in netlists of various formats, and it visualizes a schematic, generates a schematic. So we also have the ability to navigate, trace, and debug. So you can double click on a module and it opens up just like peeling an onion, and you can actually get to the leaf cells of the components. So for example, with the design hierarchy, here we can see that we're reading in different dialects, Spice, Spectre, CDL. We also have the ability to read in parasitic files such as DSPF and SPEF. If you're reading in netlists, there are parser options where you can enable to reduce the complexity of the design. For example, you may want to ignore capacitor of a certain threshold or even short out resistors. There's also the ability to enable the switch that recognizes common CMOS gates. So if you have an inverter or transistor, PNP transistor connected to NPN, you have an input and output, most likely it is an inverter, and we will represent that inverter by a symbol. But you still have the ability to double click on your design. So what we do is we read the netlist. In this case, on the left hand side you see the hierarchical tree. On the right hand side you see the schematic being generated. Just like before, you have the ability to cross probe into the schematic. You also have the ability to cross probe into the source code. And using the drag and drop, you can go to various objects in the design. You have the ability to highlight nets. If you're tracing, for example, a path, an input path or an output path, you do have the ability to trace and highlight nets of various types. Navigating. So there is an option called navigate nets and navigate signals. And I'll go into the demo. So as your designs get rather large, we have this methodology called the divide and conquer. And typically what happens is you're only interested in looking at a particular branch in your circuit, not the whole circuit. And to speed up the analysis of schematic rendering, you copy that object into what we call the cone window. And then you can double click on the inputs and the outputs, and we generate a netlist appropriately. And in some cases, you don't want to continuously keep clicking away at the net. So there's an option called navigate net or navigate signal. And what the difference is that when you navigate a signal, you actually see all the branches that connect to a particular net. So on the right-hand side, for example, you can see some transistors that are driving another set of transistors in another logic gate. We also have what we call a connectivity lens. And the example here is I have this output of this capacitor and it's going off screen. So I can do two things. I can scroll over all the way to the right-hand side to see where the objects are going, where the capacitor is connected to, or I enable this connectivity lens, which is like a magnifying glass. So in this example, we can see that the net fans out to three other branches. There's one seems to be a resistor, another one resistor, and then there's looks like another one to be a transistor. If I wanted to trace the net through the transistor, all I do is double click the transistor, and the schematic now gets rendered where the transistor will be on the screen. And if you wanted to trace the resistor, you click on the resistor, or even the pin 2, for example, of that resistor R10. If you click pin 2, that pin 2 will be highlighted and centered in the screen. We do have the ability to prune the design through segmentation, and there is through fragmentation, not segmentation, sorry, through what we call a cone extraction path, and I'll show you that through the demo. You also have the ability to save the design as a fragment, and you do have the ability to save that design as a SPICE fragment, for example, and you can actually run that fragment through your simulation tool. As mentioned earlier, this is not a simulation tool, it's a visualization tool. For documentation control, there is very rich printing and saving capabilities. So you can print, for example, or save the schematic view, the cone view, or even the whole hierarchy of a design, and you can save it or print it to various file formats or size formats, as you can see here. The tool has a very rich ability to be queried. Under the hood, what happens is the design is internally read and a database is created, and you can query that database. An example is you're trying to find a hanging net in a SPICE netlist. There is a script that traverses the net through the hierarchy, and it can report all the occurrences. So with the tool currently, there are about 100 Toggle scripts, and these scripts were requested by customers, and the source code is available for you to use. If you are looking for a script, please look at one of those scripts that are available in the installation tree. However, we can have R&D help you customize and modify those scripts for your own environments. So some of the scripts, for example, you're trying to perform electronic rule checking type of scripts. You want to find floating gates, inputs or outputs, or coupling capacitors in a heavy parasitic design. We also have the ability to import and annotate synopsis prime time timing information on a netlist. We can flatten and create hierarchical designs. As long as you know the hierarchical separation character, we can do that. We also have the ability to generate PDFs, and I'd shown you earlier a slide on that. Some other utilities that have been created. People are interested in doing ECO changes. You want to rename an instance. There are scripts to do that within a tool. So with the scripts, there's a little jigsaw puzzle that you enable on the screen. For example, in the middle here, it brings up a dialog box, and you can select your scripts. Here's an API example of a violating timing path from prime time. And the report is being read into the tool on the left-hand side. The timing information on line, for example, 37 is being annotated on the schematic. And on the right-hand side, I've just blown it up where you can actually see the timing path and the information being reported. Another example at the bottom is you have a pretty heavy-duty netlist that has a lot of parasitics. You're trying to identify where the coupling capacitors are. So the tool will identify the coupling capacitor, and you can double-click your mouse, and it'll be highlighted. Here's an example of recreating hierarchy from a flat design. So for example, this is a flat design, and here's some inverters, some modules here. We've recreated the hierarchy, and you can go vice versa. We do see customers who have specifically CDL netlists where they're typically flat. They want to recreate the hierarchy. Another example of an API is the ability to identify differences between two designs. Now, the designs have to be either both in SPICE both gate level or both RTL. It's not an equivalency checker or where you can do a gate to RTL netlist comparison. They both have to be on the same format. So this slide, what I'm illustrating is there's two examples. In this case, it's an AND gate, and there's a net reported in red, net reported in green in the second visualization window. And you can see that in this case, this net in red fans out to 3 objects, whereas the net in the second case only fans out to 2. So in this case, we're doing a net by net comparison in the design. So let's talk about some of the SPICE and transistor level. So what I talked about earlier is some of the common features across all platforms. When I mean platforms, if you did do RTL or gate, you also have the same capabilities because it's the same unified cockpit within SPICE or Netlist. But since this is a parasitic webinar, I'm mainly going to focus on the SPICE today. So the tool itself, what it does, it reads in your SPICE netlist and create what we call a general sort of digitized netlist. But then there's a mode called analog mode there where you can switch, click a button, and then it sort of remaps it like you're drawing a netlist out on a napkin, for example. In this case, the bottom one, the powers, or all the transistors connected to the same power rail, all the and the same ground rails. So this is an example how we can make your netlist less complicated. For example, this is an inverter and it has a lot of parasitics. So there's a couple of ways we can reduce the complexity. You can drag and drop the schematic into a new visualization window, and this visualization window removes all the parasitics. Or as you read in the netlist, using parser options, you can remove the parasitic. So for example, now you can see that the left-hand picture has been remapped into the right-hand picture. And I'm a digital engineer, that's my experience, but I can see that this looks like a bank of 4 inverters connected together. We can also go one stage further to reduce the complexity, and it's called enabling a merging of transistors. And in this case, we've taken the previous example and used a multiplying factor where you can see this m equals 4. And then one stage further, we can do automatic logic recognition. We can change this transistor into an inverter symbol. So in summary, we have the ability to go from something this complicated into something like this very quickly with a few switches and a few drag and drops. We introduced a new capability of the tool called analog simulation waveform analysis, and you have the ability to import simulation data. Again, this isn't a simulation tool, but we do have the ability to annotate that simulation data onto the netlist, and the various waveforms that we support are listed. For example, PSF are the most common we see, and TR0. So here's an example where we're looking at some signals using some waveform cursors, and that information gets annotated on the list. And I have a demo for that, which I will show. Now I'd like to talk about the post-layout parasitic visualization, and this is where most of you have been patiently waiting for. So what we do is the tool reads in the couple of files. It can read in the parasitic directly, or you can read in your netlist and superimpose your parasitic file on top of the netlist. Now, typically the parasitic files are very, very large. So by default, we do not show the parasitic information on a net by net basis, but we do show the nets. Now, to show the parasitic information on the net, what we do is we enable a menu option, for example, show parasitics. And what happens is that you now see in the bottom window, which is called the parasitic view, the parasitic elements on this net. On the left-hand side, you have the ability to click on the objects, and then you'll see that it's highlighted. And again, I will show you in the demo how this is done. We also have the ability to trace different nets. For example, this is illustrating another couple of branches, and we're using highlighting as an example. I also have the ability to write this out as a Spice file, a DSPF, or a SPEF, which you can use your simulation tool to analyze just this particular branch. We do have some skill scripts that you can use so you can export this seamlessly into Cadence Virtuoso. And the utilities are available for you within the installation tree. So let's jump into a product demo. And what I plan to do is just show you about some Spice examples and go into a parasitic demo and then jump into an analog waveform. So what I'm going to do now is I'm going to pause recording, and I will. So now I'm sharing the StarVision main GUI. And again, if you're using Spice Vision, Gate Vision, or RTL Vision, the GUI will be this. You'll still have the same look and feel. So let's pick up a couple of examples that I'd like to show. If you're not sure, it's a very simple tool. You don't need too much regarding reading the instructions. If you mouse over some of the icons, you'll see these little tooltips. So for example, this folder, we can read Spice. So let's go ahead and read a simple Spice design. In this case, it's an Intel-based Spice design that I'm going to go ahead and read in. So there's a couple of options that I talked about earlier. If we wanted to recognize CMOS gates, we can enable this option. If I wanted to perform Netlist reduction, there's some options available here. And if we're not sure about the power on grounds, we could specify these options. So let's enable the power on grounds. So let's go ahead and read in the design. So the tool, what it does is it generates a tree on the left-hand side, as you can see here. And on the right-hand side, the tool will generate a schematic. By using my mouse, I can zoom in. So for the example, this is a zoom fit in this direction. In this direction, if I drag it, it's a zoom in. If I drag it in this direction, it's a zoom out. I can drag it further, it gets zoomed out completely. If I drag it in this direction, I can zoom to the top, and I'll show you an example of that. So let's do zoom fit. So this is the design, and I'm looking at various objects, so I can now dive down into the various modules. And if we notice carefully, for example, this is a DF flop, it has all the transistors in there. I can use my cursor, I can highlight different blocks of the design, and I can go ahead and highlight the paths and start traversing all the way through the logic. Now, as I mentioned earlier, in some cases, the designs get rather large. What I can do is I can drag a transistor, for example, into the cone view. And then I have the ability to traverse the logic through the cone. As you can see, I'm going through the various hierarchies all the way to the reset, for example. And I'm interested in finding where this reset is connected in the source code. I just drag and drop, and you can see it's connected here. I'm looking at some other parts of the circuit. I can drag and drop into the schematic, for example, and we can see that the int A is highlighted here. We also have options to zoom in, zoom out on the buttons here. So let's say I'm interested in tracing some logic through this design. So let's say I'm looking at the ready signal. Now, if you notice carefully, if I just mouse over some of the signals, a menu option opens up, not a menu, a little tooltip, and we can actually see the the file name, and the file location. So I'd like to trace ready through the circuit. I can do a couple of things here. Ready is highlighted here. There's another option called automatically highlight. So now I'm going to highlight everything, and then I can zoom through, double click, keep double clicking. Now, sometimes this becomes rather tedious. There's an option called signal mode, which I'll enable. Let me go back to the top of the design. I'm going to reselect this ready signal. And there's an option called navigate signal. So we can see that that signal ready goes through a port, through pins. I want to show the full hierarchy. It's added various other logic. And I click this option, load to cone. And now I go to the cone window. Go ahead and close this. We can now see ready has propagated all the way through these sub-circuits, all the way to these transistors. And then again, I can traverse forwards and backwards through the logic. So these are some of the basic capabilities that I have within the GUI to drag and drop and trace. There are some menu options here. If I'm looking at, for example, an instant count, here we can see that there's about 3,000 modules and about 20,000 primitives, of which there's about 10,000 CMOS and 10,000 PMOS is there. You can see that. Okay, so what I've just shown you is the basic capabilities of the tool within the navigation capabilities. So what I'll do now is I'm going to switch gears and bring up a Spice file, a Parasitic file. In this case, it is a SPEF file that I'm going to read in. Go ahead and read. Again, on the left-hand side, we have the hierarchical tree. I can see the various nets. I can drag and drop the nets into the schematic to trace them in the design. I can take them into the cone view and start tracing forwards and backwards, even go into the source view, see where they are. But what I'm interested in doing is, my fellow colleague has told me that there's some problems with this design, specifically with the RxD input of this design. So what I can do is, let me go ahead and find the RxD signal. Again, drag and drop it into the schematic. I'm going to highlight it in a color here. Let's go highlight it 9. And I'm interested in tracing the parasitics on this specific branch. So let's use a different highlight color. Let's say red, for example. Highlight red. I right click, and there's an option called load parasitics. And I'm going to also append the parasitics on this branch. So what I've done now is let me make this smaller. I'm looking at the parasitic elements all on this net here and this net here. I have the ability to zoom in, and I'm interested in looking at this parasitic or this components. I can drag it into the source code, and now I can see where this resistor is, for example, or this capacitor. I drag and drop, and it now tells me where the capacitors are. I can click on the option here. It's telling me the resistance values, the drivers, it's highlighting the paths, the values, the grounds also through this design, which are available to you. Now I'd like to show one thing. I talked about these API scripts, and we call them user-aware scripts. So there's one specific one that's very useful to help you debug your parasitics. So I'm going to enable this plugin, and I'm going to search for a script called Debug. In this case, it's called Debug SPF. I activate it, I close. There's an option that got added to the Parasitic window called Debug SPF. And now what I'm doing is I'm looking at the net capacitances in the design. So as you'd expect, the reset will have the highest, and I can traverse through the logic and see the specific DNets on this parasitic file that's rather large. Okay. And as I'd mentioned earlier, let's make the assumption that this branch is causing some delays, and I'd like to analyze it further in my simulation engine. I can right click and I have the ability to save this particular branch that I've copied into the parasitic view as, for example, SPF. You can save it into a file, USB file. I won't save it. But now you can take that SPF file into your simulation tool. And there are other options that we have available to us. For example, if we wanted to merge all these capacitors, we can use another API script to combine. So let's find if we needed to, we can combine these with a script. I can show that later. Okay, so let me jump now into another demo that I wanted to share. It's where you have the ability to annotate your simulation data onto your netlist. So let's pull up a new design. Let's go read. So as you can see, this is a very simple operational amplifier. I'm going to go ahead and close the parasitic windows. I'm going to close the debug window. And now what I'm going to do is I'm going to open up a waveform and read in the simulation data information. So what we see on the left-hand side, we can see the values on the circuit. I'm going to choose a couple. Let's see the current on the capacitor. Gets highlighted here. I'm going to get the current on the resistor. Gets highlighted here. I can drag and drop that into the schematic. I can also drag this one into the schematic. And we can use cursors to cross-probe the data and find various values. Now let's go into the operational amplifier. Just pick one that I know. I'm going to drag it into a new plot window. I also want to find that on the netlist. Let's make this a bit smaller so you can see it. And I want to trace that simulation data on that transistor, for example. So here we can see it's 3 point something. I can add cursor values. I can move this again to different areas of the design. I also have the ability to annotate different information. For example, here I can cross probe some data. I also have the ability to represent this as different options. Here we go, magnitude in dBs, angles, imaginary parts, and real parts. I also have the ability to change the variables or the symbol line or a data point. I can change going forward. This concludes this short, brief introduction on some of the capabilities of what StarVision can do. If you would like more information or would like to schedule a product demo, please do not hesitate to contact us. Our information is displayed. Thank you.